All right, these are problems 6 through 9 on review day 13. This one gives us a graph. It's real important to see that that's a graph of f, not f prime, because what they ask us to do is to find the integral of f prime from 0 to 12. So this is not f prime. So if you were starting to do area here, I'm sure that answer is one of these, but that's not what they're going for. Instead, what you needed to do was to integrate f prime into f, and then evaluate it from 0 to 12, which would be f of 12 minus f of 0. So a little sneaky, f of 12 is negative 4, and f of 0 is 4, so we get negative 4 minus 4, which is negative 8. Okay? And that'd be our answer for that one. Next one gives us an equation, and it says which of these differential equations is this a solution for? So it's really more about this kind of a problem where you have to be speedy. So we want to take the derivative of this, which would be 2 times this again times 6, so 12e to the 6x, and then this would go away. And if we needed a second derivative, it would be 12 times this times another 6, so that would be 72. And they're really just, because you don't have a calculator, you kind of have to move quickly through these and try to be as careful as you can. So let's just test A. The first derivative is 12e to the 6x minus 6 times y, which is all of this, and then minus 30. And we want to see, does that equal 0? So this first part, we're going to get a negative 12e to the 6x, 12e to the 6, so that will cancel. And then we're going to get a positive 30 minus 30, that cancels. Hey, got a little bit lucky there, right? Got it right away. If you had time, you could test your other ones too, just to see if you made a silly mistake, but that's the idea. You're just testing them as you go. So for example, if we tried C, this would be 72e to the 6x minus 5 times the first derivative minus 6 times y, which is this. And we're going to get a negative 60e to the 6x. Here we're going to get a negative 12. So what happens is the e to the 6x is canceled, but we're going to have a 30 that's left over here that doesn't go away. And so that's what will happen for 3 of them, but 1 of them will stay there. This one says, at what value do we reach a minimum value? So anytime we want maximum or minimum, we got to be thinking critical point. That very easily could be one of your free response kind of questions. So we're going to take the derivative, and so it'll be 4/3 times 3, which is 4x to the 1/3 minus 2, and what we want to do is set that equal to 0. And so we're going to get, add 2 divided by 4, we're going to get 1/2 equals x to the 1/3, and then I'm going to cube both sides here, and it gives me 1/8. Okay, so that's my critical point. You really should test it, so we should go 0, 1/8, 1 for x, and then test these into the function, because they might have been sneaky. Maybe 0 ends up being the, so if I put 0 in, I'm going to get 0 for that. If I put 1 in, I'm going to get 3 minus 2, which is 1. So if I put 1/8 in, this is where it gets really hard. How do I do 1/8 to the 4/3, right? So the third root of 1/8 is 1/2. We did it kind of the backwards of this. If I do 1/2 then to the 4th power, I'll get 1/16. I'm going to now multiply that by 3 and then subtract 2 times 1/8. So I get 3/16 minus 1/4, which is 4/16, and that does give me a negative 1/16. Oh, some ugly math that you have to do in there to see that it's negative. Now, if you get to the 1/8 and you just want to roll the dice, you would have been lucky on this one. 1/8 is the place where that minimum occurs. But this, technically, if you're doing free response, which we will be doing, this is what they'll want to see. So this alone won't cut it. We have to get all the way to there. Hopefully, they're not jerks and give us fractions to work with, but you never know how cranky they are right now. All right, the last question here says, storage tank is empty, begins filling with water. Which of the following is the best interpretation of the fact, the the water is increasing at a rate. So WT is already a rate. That's important, right? Because now we're going to take the derivative of W. So this is the rate of the rate, right? This is how the rate is changing. So 2 hours after the tank begins filling with water, the depth of the water is increasing at a rate greater. This is just talking about the first rate, right? That's what W. If it was W of 2, then yes, but not what we are seeing here. Over the first 2 hours, the tank begins filling with water. The depth of the water is always increasing at a rate greater than 2 feet per hour. Again, that would be talking about W2, and it would have to say a little more than just what's going on at 2. Okay, 2 hours after the tank. So now we're talking about what's happening at that moment, which is what this is saying. 2 hours after the tank begins filling with water, the rate at which the depth of the water is rising is increasing at a rate greater than 3. That's exactly what we're talking about here. Okay. And then D, over the first 2 hours after the tank begins filling with water, the rate is rising, increasing at a rate greater. So this is talking about over 2 hours, like for the whole time period, and that's not what that's describing.